So we are going to calculate the inverse of a matrix using the row operations method. So this is problem 8.6.25 in the textbook. And there is a theorem that says if we have some matrix A whose inverse exists, and some sequence of row operations R transforms the matrix A into the identity matrix, that same sequence of row operations, if performed on the identity matrix, so I under the sequence of row operations R will turn I into A inverse. So a very easy way to perform the same sequence of row operations on both A and I at the same time is to construct the augmented matrix A, I, and then perform some sequence of row operations on this augmented matrix. So again, this is R that gives us I on the left side of the augmented matrix. Then, because of this theorem, on the right side of the augmented matrix, we will have A inverse. So let's go ahead and do that. So the first thing I'll do is construct this augmented matrix here. So, on one side we'll have A, 1, -1, 2, 1, 2, 0, 1, 1, 3, 2, -3, 2, 1, 1, 0, 1. And on the right side, we will have the identity matrix. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And so let's begin our row operations. So we don't need, for the first row, we don't need to do anything with the first column. It already has a leading 1. So we will do row 1 plus row 2 becomes the new row 2. -2 row 1 plus row 3 becomes the new row 3. And negative row 1 plus row 4 becomes the new row 4. After that, we will start with 1, 0, 0, 0, 2, 3, 1, 1, 0, 0, 0, and then 2 plus 0 is 2, 3 plus 2 is 5, 1 plus 1 is 2, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. That doesn't change. And then -2 times 2 plus 1 is -3. -2 times 3 plus -3 is -9. -2 times 1 plus 0 is -2. -2 times 1 plus 0 is -2. -2 times 0 plus 0 is 0. -2 times 0 plus 1 is 1. -2 times 0 plus 0 is 0. Negative 1 times 2 plus 1 is -1. -1 times 3 plus 2 is -1. -1 times 1 plus 1 is 0. -1 times 1 plus 0 is -1. And the rest of this row are zeros, so this will remain 0, 0, 1. Okay, so now I will actually I will swap these two rows. So swap row 2 and row 4, and that will give the same matrix, but with those rows swapped. So I'll just copy this, paste it down here. And then swap the rows. So now I will multiply row 2 by -1 to put a 1 in position 2, 2. So negative row 2 becomes the new row 2. I will also go ahead and eliminate everything else in that second column. So I'll have 2 row 2 plus row 1 becomes the new row 1. Negative 3 row 2 plus row 3 will become the new row 3. And 2 row 2 plus row 4 will become the new row 4. After this, I'll have 1, 0, 0, 0, 0, 1, 0, 0. Then 2 times -1 plus 3 is 1. 2 times 0 plus 1 is 1. -1 times -1 is 1. -1 times 0 is 0. 3 times negative 3 times -1 plus -9 is -6. -3 times 0 plus -2 is -2. Negative 2 times -1 plus 5 is 3. 2 times 0 plus 2 is 0, is 2. And on the right side, I'll have, let's see, so -1 times -1 is 1, stays 0, and that's -1. Then 2 times -1 plus 1 is -1. 2 times 0 plus 0 is 0. 2 times 0 plus 0 is 0. 2 times 1 plus 0 is 2. And then -3 times -1 plus -2 is 1. -3 times 0 plus 0 is 0. -3 times 0 plus 1 is 1. -3 times 1 plus 0 is -3. And then 2 times 1, 2 times -1 plus 1 is -1. This stays the same, 1, 0. And 2 times 1 plus 0 is 2. Okay, now I'll do the third row. So it doesn't really matter which we do, so let's divide by 6 here. By -6, so -1/6 row 3 becomes the new row 3, and that will give us, just duplicate this, it over, divide this row by 6, by -6, so this is 1, -2/6 is 1/3. 1/6 is -1/6. 1/6 is -1/6. -3/6 is 1/2. Okay, so now we eliminate everything else in this column, so we'll do negative row 3 plus row 2 will become row 2. negative row 3 plus row 1 will become row 1, and negative 3, row 3, plus row 4 will become row 4. So that will give us 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. 1/3 times negative 1 plus 1 is 2 over 3. 1/3 times negative 1 plus 0 is negative 1 over 3. This stays 1/3. 1/3 times negative 3 plus 2 is 1. And so on the right side of the augmented matrix, we will have negative 1/6 times negative 1 plus negative 1 is negative 1 plus 1/6, which is negative 5 over 6. This was 0, and so this column will remain unchanged. This row will also remain unchanged. Negative 1 over 6, negative 1 over 6, 1/2. Negative 1/6 times negative 1 plus 1 is 7 over 6. Negative 1/6 times negative 3 plus negative 1, so that would be 1/2 plus negative 1, or negative 1 over 2. Negative 1 over 6 times negative 1 plus 0. These will both be 1 over 6. And this will be negative 1 over 6 times negative 3 is 1/2, plus 0 is 1/2. Okay. So, negative 1 over 2 times negative 1 plus positive 1 over 2 times negative 1 plus 2 is 3 over 2. Positive 1 over 2 times negative 1 plus negative 1 is negative 3 over 2. Positive 1 over 2 times negative 3 plus positive 2. So negative 3 over 2 plus 2 is 1 over 2. Okay. So now we already have a 1 in position 4, so we just need to eliminate that column. So these calculations can get a little bit tricky. So I'm going to use a calculator to compute all of these, but I will still write out what all of the multiplications need to be by. So we want to eliminate the final column, and to do that, we will add negative 2/3 times row 4 to row 1. That would become the new row 1. Positive 1/3 times row 4 plus row 2 will become the new row 2. And negative 1/3 times row 4 plus row 3 will become the new row 3. After this step, we will have on the left-hand side the identity matrix 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And on the right side, we will have negative 1/2, 1, 0, negative 1/2, negative 2/3, 1/3, negative 1/3, 1, negative 1/6, 1/3, 1/3, sorry, -1/3, 1/2, 7/6, -4/3, 1/3, 1/2. And this right side is A inverse.